I am going to solve this integral by parts and tricks up, right? So I'm going to start off with the differentiation, the integration by parts. I beg your pardon. So I'm going to differentiate the tan inverse of x because it's easier to differentiate that, and I'm going to integrate the rest, which is x over x squared plus 1 squared, right? This is plus, next one is negative, right? Differentiating the tan inverse of x is 1 over 1 plus x squared. What about integrating this? Let me do that here real quick. So we are integrating x dx over x squared plus 1, all this one squared. What is the integral of this? So I'm going to multiply this one by 2 and then divide the integral by 2, right? And then do a u sub. I'm going to let u to be equal to the denominator, that is x plus 1, x squared plus 1. So du is going to be 2x dx. So it means I have to replace 2x dx with du on top here, divided by u squared. And now integrating 1 over u squared is negative 1 over u. But it's already multiplied by 1/2. So that is going to be negative 1 over 2u. And then u is x squared plus 1. Right? So when I integrate this, this is the answer I'm getting. So I'm just going to write it here and then we apply the integration by parts. And that is negative 1 all over 2 multiplied by x squared plus 1. Cool. And now let me clean this one and then we can deal with that. And now what we normally do, when we multiply terms diagonally, there is no integral. We are done with the integration, but when we multiply terms horizontally, we have to take the integral. I is going to be equal to the integral, so multiplying terms diagonally, that is going to be negative the tan inverse of x. This is divided by 2 into x squared plus 1. Right, we are done with the integration. Take the limits of integration from 0 to infinity, and now be mindful of this. When you multiply them, that becomes positive. The integral from 0 to infinity of 1 all over 2, which is multiplied by 1 plus x squared, and then another 1 plus x squared dx. Right, so this is what we have after the integration by parts. So now let's take the limits. The limit here, we have negative 1/2, which is a constant, and then I am going to take the limit as x approaches infinity of the tan inverse of x divided by x squared plus 1. This is the upper limit minus the lower limit. When you plug in 0, that is going to be tan inverse of 0 is 0 all over 1, which is 0. So it's 0 for the lower limit. And then plus 1/2 is constant, and then the integral from 0 to infinity of 1 all over. This is now 1 plus x squared, all this 1 squared dx. All right, I is equal to negative 1/2 in front here. As x is approaching infinity, tan inverse of x is approaching pi over 2, and this is approaching infinity. So pi over 2 over infinity is 0. So this is 0 minus 0. So the limits evaluates to 0. Then you are going to add half the integral from 0 to infinity of 1 over 1 plus x squared, all this 1 squared, and then dx. So what we are just integrating is 1/2 the integral from 0 to infinity of 1 all over 1 plus x squared, all this 1 squared dx. So using integration by parts, we have now ended with this integral, which we are now going to apply the trig sub. So the trig sub, I am going to let, and this is obvious, x is going to be equal to the tangent of theta. So when we do this, theta is equals to what? So dx is going to be equal to dx here is going to be equal to secant square of theta d theta, and that is the differential of the tangent of theta, right? The change in limits when x is equal to 0, right? That is the lower limit. Theta is going to be equal to the tan inverse of 0, which is 0. And when x is equal to infinity, the upper limit, theta is going to be equal to the tan inverse of infinity. Tan inverse of infinity is pi over 2. And now the integral in the theta world is looking like this. I is going to be 1/2 the integral from 0 to pi over 2 now of 1 all over 1 plus tangent of theta by a squared, so tangent square of theta, and all this one is squared, multiply by dx, and dx is the secant square of theta d theta. Cool. I is equal to 1/2 the integral from 0 to pi over 2. This is 1 all over, from the Pythagorean identities, right? We know that the tangent square of theta plus 1, this is the same as the secant square of theta. So what I'm going to do is to replace this one with the secant square of theta. So this is the secant square of theta by a squared as well, and this is multiplied by the secant square of theta d theta. Cool. So we have I to be equal to, this is now secant to the 4th power of theta, which is going to cancel this one. So that is going to be left with 1/2 the integral from 0 to pi over 2 of 1 all over secant square of theta d theta. So that is what is left. And now 1 over secant square of theta is the same as the cosine square of theta. So the integral from 0 to pi over 2 of the cosine square of theta d theta. This integral is not trivial. So let me write it here, and then we apply a property to solve that. And then we are going to have the cosine square of theta d theta. So we know from the double angle identities, we know that the cosine square of theta, this is the same as 1/2 into 1 plus the cosine of 2 theta. This is the property that we are going to use to solve this integral. I is going to be equal to 1/2 the integral from 0 to pi over 2, and in place of that is going to be 1/2 into 1 plus the cosine of 2 theta d theta. So 1/2 is a constant. It comes in front and multiplies this 1/2. We have 1/4 the integral from 0 to pi over 2 of, and now I have 1 plus the cosine of 2 theta, like this, and then d theta. Now shall we integrate? That is going to be 1/4, and then integrating 1 in the theta, well, is theta, and then integrating cosine of 2 theta is 1/2 sine of 2 theta. This is what we have, the limits of integration from 0 to pi over 2. I is equal to 1/4. This is theta plus 1/2 sine of 2 theta from the double angle identity is 2 sine of theta cosine of theta. Limits of integration from 0 to pi over 2. Now I is going to be equal to 1 over 4, and then what do we have? This is theta plus sine of theta cosine of theta. The limits of integration from 0 to pi over 2, because this and this is going to cancel out. And now let's put in the limits. So 1/4 outside, and then we are going to have pi over 2. This is the upper limit, right? Pi over 2 plus sine of pi over 2. Sine of pi over 2 cosine of pi over 2. This is the upper limit minus the lower limit. The lower limit is going to be 0 plus sine of 0 cosine of 0. All multiplied by 1 over 4, and then this is going to be 1 over 4. And then what do we have? This is sine pi over 2. Sine 90 is 1. Cosine of 90 is 0. So everything here is 0, right? And now when we come here, sine of 0 is 0, cosine of 0 is 1, everything here is 0. So everything is 0, it's just left with pi over 2. And that simplifies to pi over 8. Therefore, this integral evaluates to pi over 8. As simple as that. So this beautiful integral evaluates to pi over 8, courtesy integration by parts and a trig sub. So this is a very simple integral. If you find that helpful, please give me a thumbs up and subscribe to Calculus Diaries for more engaging content on integrals. I thank you, and I'll see you in the next one. Bye bye.